Okay, folks, in this video we're going to just go through a couple of quick examples of how one could necessarily write the equation of a quadratic function given two pieces of information. Those two pieces of information would be, of course, where's the vertex, and give at least 1 point on the function or the parabola. Okay, so I write here, it's the case that if we're already aware of the coordinates of the vertex and at least one other point on the parabola, then we can write the equation of this graph. We just need to do this by plugging in the vertex values for h and k respectively. And what I'm referring to is this. We say all equations that are quadratic can be expressed in this standard form like this, where the vertex, recall the vertex is at the point h comma k, and has some a value here, okay? But we can write it like this. We'll just plug in h and k if we know the vertex already for h and k in the formula, as well as plug in the values of x and y of some coordinate on the point or on the graph in for x and y here. Okay, so we're going to be plugging in for those four underlined values right there. Let me emphasize those in color. These four here, you'll notice in my instructions over here, then we'll back solve for the a value. So essentially the only thing we're not aware of yet is this a value, and once we find that, then we can just plug everything back in. So let's go ahead and go through a couple examples. It'll make total sense. So we say, first of all, example A, we know the vertex of our parabola is at -4, 11. So we say, if I had to get a conception of this graph, we say -4, 3, 4, somewhere up here. Okay, so we say this is like our vertex and vertex. And we say -6, 15. So -6, 15. So this is a height of 11. We say a height of 15 would be like up here somewhere. I just wanted to point this out because I could see that this must be my parabola, and so it's got to open upward. So it gives me an idea that at least my a value is positive. But let's go ahead and work with what we have right now. We say the vertex at hk, we say h is -4, k is 11. We have an x value, we have a y value, and so listing all of this out, we'd say y equals a times x minus h quantity squared plus k. And so just to emphasize this, we say this is a y, this was our y, this was our x, this was our h, this was our k. We're just going to plug things in. And so we say the y value of the point on this graph is 15. We'll put a 15 over here, so 15. Let's see, we need an x value here. Well, the x value of the point on our graph is -6. We say -6. Our h value, it seems, is -4. So we do have a double negative. It's very important you put in parentheses here. And then we say the k value is 11. And so simplifying this, we'll clean it up a bit. We say 15 equals a times the quantity. Now -6, take away 4 negatives, same as -6 plus 4 positives, is -2, and that's being squared. And this is plus 11. So you see it gets really, really cleaned up on the right-hand side here. We say a times the quantity. Well, -2 squared is 4, so times 4 plus 11. And so essentially it becomes this two-step equation where we have 4a plus 11 is the same thing as 15. And so if we kick our 11s from both sides here, we end up producing, or this implies that 4a, I'll put this on the left, is equal to 15, take away 11 is 4, and a is 1. So this is our a value. And so we can finally finish this up here by plugging everything back in. All we need now are a, h, and k, just like any other time of the day. You want to write the equation of a parabola. So we say y equals, we'll leave y general this time. We say a, which is 1, times the quantity x minus h. H from up here was -4, so x minus h is -4. So this becomes plus a positive quantity squared. Of course, that's very important. And we say plus k is 11. So the simplest form of this equation would be x plus 4, that quantity squared plus 11. And looking at the graph, it seems that we have a vertex was at -4, 11, and kind of looks like we have an a value of 1. It did certainly open up. So looking at this second example, example B, it's kind of the same thing except we're starting with the graph. And so what I want you to notice, and I'll point this out to you here, is we have the vertex. It'd be the same thing as the last problem, but I say identify the vertex. B is at the point, looks like 1, 2. And we don't know the a value, but we say through a point, through the point 2, 0. So again, let's go ahead and plug things in. We say y equals a times the quantity x minus h, quantity squared plus k. And remember a, we did not know a, so we leave a as a. But it looks like the y value of the point that this passes through is 0. Awesome. The x value is 2. The h value, h, okay, is 1. It's a positive 1 this time. And the k value here, oh, I can't believe I did that. This k value is 2. So again, let's clean this up. We get this. We say 0 is the same thing as a times the quantity 2 minus 1 squared plus 2. Okay, 2 minus 1, is 1. 1 squared is 1. Don't tell me it's 2. So we say really 1a, or a plus 2, is the same thing as 0. Then we must have the case that a is negative 2. And this is awesome because if a is negative 2, and we know the vertex is at actually 1 comma 2, we can actually just go ahead and fill in all this information into our equation. We say y equals a, which is negative 2, x minus h, in this case h is 1, that quantity squared plus the k value of 2, and here's our equation. And just to see that this makes reasonable sense, look at the vertex. It is actually at 1 comma 2, and with an a value like negative 2, like negative 2 over 1, from the vertex it did go down to right 1 to get to the next point on its graph. So wonderful.